next speaker is Mehrdad.
Mehrdad, yes.
Founder of Ubo, yes. Locally famous Raspberry Pi-based platform for building rich UI applications. He's building hardware products for the last decade, and now he's going to share some of what he's learned about that with us.
Thank you for the introduction. Thanks for joining the talk. Today I just wanted to share some lessons that I have learned during hardware development that I have done over the last decade. I can probably share everything in a 12 minutes talk, but I wanted to contrast hardware development with software development, and then things that you can do during hardware development to de-risk and also expedite your hardware development cycles. So basically, when you are doing software development, comparing software development cycles and hardware development cycles, there are some differences. For example, every time you are iterating on your hardware, you have to make something and then test it, versus in software, you don't have the make process. I mean, you are doing a make process, but it's very quick. So you don't have to wait for the part. Even if you're 3D printing, you still have to wait for the 3D printer to make it. So there's a build cost. I'll call that a build cost. So you have to kind of minimize your build costs in software hardware development, because the more builds you do, the higher cost of development you're going to have. Also, when you make a mistake in software development, you can always, do a software patch or push a new update, software update. But in hardware, you can't do that. Like if you make a mistake, you just have to scrap that hardware, put it in the trash, and then basically you lose all the money that you've spent in whether it's a prototype or a production hardware. It better not be a production hardware, because at that point you go bankrupt, because you have to scrap all the production that you have done. And then the testing, software testing, you can write unit tests, integration tests, regression tests, different kinds of tests, and run it. In hardware, there's the same concept of testing, but when you're doing hardware testing, you need test rigs. Now you have to make another piece of hardware to test your hardware with it. So there's a test rig. You have to build these test rigs, which adds another layer of complexity to hardware development. So overall, your hardware build cycles are going to be minimum of weeks. So every iteration you go through, you're looking at maybe a month or two for each iteration. You can maybe do one iteration for months, but 2 months is kind of the average into your design iteration. For software, you can build something and release it in a week. So it's way faster development cycle. And then basically your time to ship in hardware is minimum 1 year. Like I've really never seen any hardware that from the idea to the moment it ships is less than 1 year. Like it's minimum 1 year, usually 2 to 3 years from the ideation to the shipping of the hardware. Software, you can probably ship in a month or two if you're doing an MVP or a very similar experience with your software. Now, the things that I have learned from the past is if it's the first time you're designing hardware, you have to be very careful with your environmental risk. The thing that I call environmental risk is that eventually your hardware where is it gonna get deployed? Is it an outdoor product? Outdoor product, I think, is one of the most challenging categories of hardwares that you can ever build, because outdoor you have sunlight, rain, snow, a hailstorm, or every kind of thing that you can imagine. You're dealing with corrosion when you're outdoor, humidity. So you have to go with IP ratings. So IP68 is probably very high bar for like being dust proof and also weatherproof and all that kind of things. But to get IP rated, you have to go to an environmental testing lab that they will put salt on your product and see if it's gonna corrode or not in the outdoor environment. And they're gonna have spray water jet from different angles at the product to see if the water is going to get in. And there are so many, and the sand and the different grains of sands, that you have. So your iPhone is not really considered an outdoor product in that sense, but it's still, they have to go through so much environmental testing. So as a first-time hardware, if you're doing hardware for the first time, I would highly encourage you to stay out of these kinds of environment, the hostile environments where you deploy your product. And then people are going to drop your product if it's like, they're going to carry it, or even the postal office is going to drop your package. So you need to, consider that as a risk in your product development. Humidity, if you're developing something that is used in a bathroom or it's a smart toothbrush or something like that, then even little humidity can go inside and corrode your circuit boards and damage everything over time. So all these are like, you have to think about different levels of environmental risk. So for the first time product, I would suggest you go for safe places like a home environment or an office environment, or something that is more controlled in terms of the environment that you're operating. So that's why I kind of went for Uber product, which is developer facing. When your customers are also developers, they might be more forgiving with the bugs in your product, because they can go and fix it. If it's open source, they can see, oh, I found this bug, and I do a pull request and I'm going to fix that bug for you. So, but if your customer is a consumer and you have a bug in your product, now you have an RMA, and they're going to send it back to you, and you have to provide the shipping label and everything to get it back. So there's also another layer of complexity in the type of customer or the user that you're dealing with. Now, what's this one? Okay, go. Okay. Now, imagine now that you're settled on what you want to build or for what environment you want to build for, there are ways you can use to accelerate your product development. The thing that I have learned about hardware is that sometimes this happens a lot with Kickstarter projects, that they launch and they have a delivery date 1 year from now, and they say we're going to have to make it because people are waiting for it, so they start developing really fast. And go fast and break things might work for software, but in hardware, that's a recipe for disaster. So in hardware, it's really slow is fast. In Navy SEAL, they have an expression that say, slow is smooth is fast. And that actually happens in hardware development. So that means that you have to take every step, test everything between every step of the way, make sure that you're standing on the solid ground before you step up and do the next thing in your hardware development. So going too fast can increase your build cost. So you can send something to China to get 3D printed, will shipped here in about a month and cost you $10. But then you can actually if you want it tomorrow, you might have to spend $1,000 to get it built tomorrow. So if you can wait, you can also lower your build cost. So one of the things that I usually do is that if I need something 2 months from now, I'm going to place the order now and pay way less for that, and waiting until I need it, and it's like, oh, I have to now place the order. It can dramatically reduce your cost in hardware. Just thinking ahead of time what you're going to need when, and 2 to 3 months is really what you need to think in advance in hardware with prototype. With production, you have to think next year where I want to be with production, because injection molding is going to be 60 days, 2 months to wait for the mold, and another month to get your samples. So you're looking at very long lead times, and there's not really much you can do. I mean, you can insist to make things faster, but it's not going to happen. And then one thing that is very important in your design is that when you design things, you have to keep two things in mind. Is this easy to manufacture? Because if you make your design in a way that uses standard manufacturing processes and even cheaper ways to manufacture it, it's going to make life much easier for you down the road. So if you use laser cutters, it's a very easy way to manufacture. But if you need to do die casting of aluminum, then it's a very complicated way of manufacturing. And then DFA is usually neglected. DFA stands for Design for Assembly. Now, Design for Assembly can remove a lot of issues down the road when you start assembling your product together. So for example, they're very techniques for assembly that you cannot assemble it in a different way. So they removes the areas of basically confusion. Like you can always use that screw here, like you cannot like misassembly. And that was developed by Toyota, like developing an assembly, I forgot the term for it, but it's like a self-correcting or supervising assembly technique that you can, it's like IKEA furniture. Like when you get the IKEA furniture, you cannot really mess up with the assembly because they make the screws or things like that, that one specific screw can only like align with a specific hole. And you want to also minimize your number of iterations. Like there's always a temptation to do another iteration. But it's best to wait until you have a whole bunch of changes made and validated in the software, in the CAD software, in your design before you spin out another iteration, because a make is going to be costly and you want to address any known issue or any design change that you want to do and validate it before you do an iteration. Yeah, so basically you also need to document all the procedures, everything that you go through, so that you can communicate that to the factory down later. Next thing that you have to keep in mind is that don't wait until you're ready to manufacture your product to talk to a factory. The way I usually start the hardware product development is that I have a very rough sketch of the product idea, and it might change a lot. But I know that at some point I may need an aluminum part or I need an injection molded part. So I start conversation with multiple factories and see which one is going to support me throughout the product development. Because when you work with the factories in China, if you do not place an order for more than 5,000 units, you're not an interesting customer for them. But you actually want to find a factory that is interested in helping you build the product at the smaller units. And so that means that you have to start the conversation early and see who is going to be willing to work with you along that line. So with some of the factories, like I start just as soon as I have an idea for the product or I have a sketch, I start the conversation with the factory, and they're probably going to build something for me 1 year after I start that conversation. So they need to kind of stick with me during that year and kind of help me. And for them, it's just going to be, we're going to stick together and manufacture this product for many years. So think out of the box a little bit. There are so many different manufacturing techniques that you can use to lower your build cost. You can do aluminum extrusion. So I have this part. You can think of extrusion as pushing something like a paste or a toothpaste through a profile, and this thing kind of comes out like this is a tube. So you got the molten aluminum pushing like a toothpaste through a cutout profile, and it kind of comes out. And extrusion is very cheap compared to other ways of making the product. And so this thing will come out of extrusion die like a bar, and it gets cut into pieces, and then they will machine it, post-process it on a CNC machine. So that's actually you can extrude plastic, you can extrude many different kinds of material, and it costs $1,000 to make an extrusion die, or even less than that. All the frames in the office here, you see, they made custom extrusion profiles for them, for just connecting these frames of offices. Vacuum forming is a very low-cost way of making things, especially if you're doing a small volume. It basically heats up a sheet of plastic and then sucks it around a form of object, so it kind of forms around a solid object, and it gives you that kind of profile. I'll talk more about compression molding. Compression molding is like a waffle maker. So we use compression molding for silicone keypads. They're the same keypads that you have on your remote control TV remote control. They're kind of flexible silicone products that you use it for keypad, but they have these sheets of silicone, and they put it in a waffle maker and they close it So with the pressure of closing, and it heats it up and vulcanizes the silicone inside the mold, and then they open it like a waffle maker, and they take out the part and do some cleaning, and you have a keypad, a small keypad that it's the same technique used for remote control silicone, and it's super cheap. You can make a single cavity mold for $200, but they usually ask one for production. You have to make 20 of these at the same time in a 20 cavity mold, which costs around $1,000, but still a very low cost compared to injection molding. So another suggestion or recommendation I have is try to modularize your design as much as you can so that you can test your modules and do like subcomponent testing. And then when you bring everything back together, you at least know that your subcomponents are individually unit tested, and then you would do an integration testing at the end. It's not trivial. I mean, some products you may not be able to modularize it, but when you look at it, like your computer has a standalone RAM or a graphics card, so these are modules. So if you can kind of build these standalone modules that you can swap them out, also it helps you in repair. If something fails, you can just swap that module and repair that. You can nowadays build PCBs with kind of with desktop pick and place machines. And desktop pick and place machine, you can make PCB boards, small, numbers of them, 10 or 50, before you're ready to move to a full-fledged production line for the PCBs. China is right now kind of like doing things. You can do things in China that is kind of going back in time. It looks like magic to me. Like you can 3D print things for $1 now, and like it's the same cost of doing injection molding. Like this piece, I can 3D print for $1 in China, and it's not worth my time spending 5 minutes on a 3D printer while I can order 100 of these in China for $1 for $100 and have it shipped, to me. But the only problem with this is the wait time. So if you don't have time, then you can't do it. But if you think in advance, even if you do not, if you just have a design that you haven't validated, you can send it to China. You're just wasting $1, right? So I sometimes spin out 10 different designs, send everything to China. They come out and then it's like, oh, I don't need any of them. They just like don't meet my spec update. I messed up my design or whatever. I lost $10. That's fine, but I didn't spend much time myself just building those. And then last one would be use your product to test your product. So it's kind of, let's say you have a product that has a specific microcontroller on it, and you can build your test rig using the same microcontroller because now you're reusing parts. So in my product, I use a Raspberry Pi, and for my testing, I also use a Raspberry Pi, so I don't have to build a dedicated test rig. It's just like kind of, it's a unique product. You may not be able to do it with any kind of product, but building a test rig can be expensive, sometimes $50,000 to just build a test rig in the factory. So if you can kind of get creative and build your own test rigs, it's going to lower your production cost. I'm gonna try to wrap it up. So this is the one that I was talking about, the keypad. So with the keypad, the first iteration was I used Formlabs resin, flexible resin, to prototype the first versions of the keypad. These are using the flexible resin on Formlabs, and these are the supports that comes out. So I have to go use a little cutter to cut all these supports because you cannot tear them apart like a solid one. So it's just like, it's a very lengthy process to 3D print this, but it's like flexible, and then the third image is used a prototype made with a technology called multi-jet fusion. It's still flexible, but not as flexible that I wanted. And then after that, I prototyped the keypad using a 3D printed mold with the Formlabs 3D printer. And then you basically put silicone inside the mold, and then you can prototype something like that. And then once you get some confidence, you can...
Sorry, I was part of the feedback.
Once you get confident with your design, you can basically go ahead and make a single cavity mold. It's $200, $300 in China, and then get something that will be basically like the final product. So basically, this is the process that I follow with prototyping. Some other techniques, like I put some numbers in terms of the cost with compression mold, single cavity, $200, 16 cavity is around $1,000, and then extrusion for solid profile, $700. I mean, you have to negotiate with manufacturers, but these are kind of rough numbers. And then for hollow profile, $1,500. With injection molding, if you have a small parts, you can build a family mold, and then basically lower the cost of injection molding per item. So let's say you have a design with a lot of gears in it, and you have custom gears. So you can put all the gears in one mold, and then the plastic will flow into individual cavities, and with one injection, you get 10 parts. Now you're like paying $4,000 or $5,000 for a mold, but then your per component cost is $500 per mold or per component. That's another technique that you can use to lower your injection molding fee cost. Last slide. Basically, this is the journey most hardware products go through in order to get to production, and it's a waterfall journey. It's like a left to right journey. You cannot skip it. You have to go through all these individual steps until you get to mass production. And usually it starts with proof of concept, and you make a few units to just ensure your concept is valid and it works. And then you move to you start doing testing. You validate your builds, and you go through several iterations there. And then you basically lock down your design and then start making more of them. So the more you go through this process, you have to make more units, do more testing, and then you have to lock down your design at some point and not make any changes, and basically improve your process. So the more you go to the right, the more processes that you have to improve, less design improvements, more process improvements. To the left, it's more design improvements and less process improvements. So when you get to scale, everything is about process. Your factory, assembly line, what are they following, like what kind of procedures they're following for QA and testing. It would be 90%, 95% process. And you have to manage your supply chain, your purchasing, inventory. This is all kind of a process that you have to kind of have in place in order to make sure that your operation is running smoothly. So towards the end, it's mostly operations, and the engineering functions kind of hand over to operations functions. And that's pretty much it. If you guys have any questions, happy to take those questions. Thank you.
Talk about price. Can you talk about the price?
So I didn't talk much about the product. So I wanted to share some lessons, but the product that we're developing right now and it's ready to go out is a Raspberry Pi based development kit. So if you're a developer making a product or working on a project that requires user interaction, so your user needs to interact with your application, Raspberry Pi itself doesn't give you any UI, so you do not have a way, the user does not have a way to interact other than a keyboard and a monitor. So if you want to run your application in a standalone way, then we offer several added peripherals. For example, if you're doing audio, you need a microphone and a speaker, right? Or if you want to show some error message or notification to the user, we give you this LED ring that you can blow different kinds of patterns to say something happened or get the attention of the user. There's a small LCD and keypad on the front that you can use for simple interaction with your application, change some settings there, or turn on and off some options. And it also has IR receive and IR transmit. So let's say you want to automate something in Blast IR to turn off TV or your AC or something like that. So basically any hardware peripherals that you need to basically build a good UI for your application. And the product the pricing is not being finalized yet, but it's kind of in the range of $200 to $250 depending on the trim of the product.
Does this will include the Raspberry Pi? Or
Yes.
not? Yes.
Yes. Initially, it will come assembled with Raspberry Pi because I would like to eliminate user errors during assembly. But once things get more streamlined, I will offer assembly instructions. If somebody already has a Raspberry Pi, they can just buy this as a kit and put it together. But that would require very thorough assembly instruction. And also it has to be tested. So it's work for the user initially. So you have to spend several more hours or maybe 1 hour to put everything together. So it's not a very smooth experience for the user either. Cool. Well, thanks for attending the talk. I think it's just the last one. So enjoy the rest of the party and see you guys around.